Thank you for joining us. For everyone that's, I'm new to RIZE here. My name is Alex Orfanos. I just joined as an application engineer. I'm going to be leading the webinar today. We have a lot to cover on this new material, and we have some guest speakers here who have experience to talk about how they've been successful with it, both Cody and Ronnie from Azoth. Thanks for joining us today, guys.
Hey, thanks for having us.
It's a pleasure to have you guys on. We'll be hearing from them later on towards the end. We're going to give you guys some upfront information, as you can see on the slide here. We'll be going through some of the topics, obviously the RIZE story if anyone's new to RIZE and our mission. We're also going to talk about the material itself, the problems that it solves. We'll touch on some applications, and then Cody and Ronnie will go further into that with us. If you have any questions for us, please feel free to use the chat function. We'll do our best to get back to you before the end of the webinar, but at the very least, we'll get back to you with any questions we don't get to today. A little bit on myself and my background. I've been in 3D printing for 4 years now, mostly FDM-based printers. I've got a few in my basement. One of the amazing things that's happened since I started is the ability to have the RIZE system in my own house and feeling safe about that. It's a really big advantage. We'll talk about that in a second. And the material I'm really working a lot with right now is this new material that we're talking about, Rizium GF. And it really is, the point to drive home today is that it's a really well-rounded material for use in almost any application. It's hard to find one that it won't work for. But let's talk about the RIZE story and kind of what our view is as a company. It's a material science focus. It's part of the whole Rizium series. Those who are familiar with Rizium 1 and Rizium ST know that we're looking for low emissions. It's about safety first, but also not just a compromise on safety and strength. Our Z-axis strength is best in class, and durability, low moisture absorption with the Rizium base, superior chemical resilience, and exceptional UV resistance. And part of our story, we're RIZE, we're the people who have invented the world's first UL 2904 certified system with safe recyclable materials. That's on the RIZE 1 and the X-RIZE system. Now, Rizium GF is still getting certified, but it all falls under our view for the future about having safe and reliable recyclable materials. So we will be getting that certified soon. Now, let's talk about a little bit about the material itself. And we didn't reinvent the wheel with glass fiber. This is glass fiber reinforced polymers, a very common use in manufacturing. So if you're familiar with the material, gives us an industry standard, provides better dimensional stability and reliability, has an overall better performance as a material. As we talked about before, the base material doesn't absorb moisture, which if you're familiar with other plastics like ABS or nylons, they are hygroscopic in nature. They will eventually absorb moisture, and having this Rizium base allows you that advantage. I know anyone who's familiar with printing nylon, if you don't have a dry box, you open that spool up the first time, and almost after that first print, it's not usable anymore. Complete waste of that material. So you don't have to worry about that with this material. It also comes along superior chemical resilience and exceptional UV resistance. Mechanical performance properties, you're looking at moderate stiffness and strength for performance, something really well rounded for a lot of different applications, and your heat transfer deformation. You have operating temperatures up to 75 degrees C before you start seeing the material become affected. Some other advantages here with the glass-filled composites, you're going to have better control over the placements of the fibers, which comes in hand for different applications like high-performance 3D printed parts for medical, aerospace, sport, and rapid prototyping applications. And just some more advantages spelled out here. One of the big advantages, obviously, with the RIZE system is full color. It's the only way to get glass fiber color with our composites there. You're going to get affordability with this. You're not going to spend the higher cost in some of these exotic materials like nylons and polycarbonates. You're still going to get strength out of it, durability, flexibility, and some fatigue resistance. Now, if we look at some stats, especially comparing, we'll go back one slide. We talked about it being a well-rounded material for use. So if we look at some of the, not only our material offerings, but some of the common ones in the industry like PLA, ABS, and nylon, you'll see that the Rizium GF here on the left in green gives you a really nice balance of both a strength and modulus for flex. And not only that, but some of the materials that you would use for, say, whether it's carbon, ABS, nylon, those filaments tend to be a bit more challenging to work with, where with Rizium GF, you're going to get some of that strength and stiffness, dimensional accuracy. You're going to get that with this material that you won't get with those others. So we talked about strength, but it's not just strength and complexity, but it's also the ability to add color. The amazing thing, especially someone who's relatively new to the technology and learning it, the thing that's very, very impressive from my perspective is just the ability of the inks to interact with the material itself. So you're not doing some crazy Z offset to apply on top of a material. The ink is actually absorbing into the material at a voxel level. So you're going to get not only the tensile strength of parts, you're going to get color parts that you're going to be able to, not worry about knocking off the desk and potentially breaking. You're going to get parts that are stiffer, that have just an overall mechanical performance. And you'll be able to get those complex geometries and add the color for if you have FEA analysis or anything like that, and not have to compromise strength. And kind of touching on the medical aspect here, especially life sciences, you're able to now print with a versatile printing material. So you're going to get high-end engineering material and color at a low cost per part. So this is kind of our advantage of combining the material science with full color capabilities. You can do anatomical models, use the scan models of actual patient-specific anatomy, create strong and complex organic shapes with or without color. You'll be able to combine full color analysis with the scan data. So you'll be able to create these digital parts that communicate more, and you won't be breaking the bank every time you make one of these. And for sterilization, and this is something we saw with our helping out the medical community with COVID response, because of this material science first approach, our Rizium-based materials have the ability to be sterilized using gamma and ETO processes, which is really not an option with a lot of different materials. The one thing that it won't be able to do from a sterilization standpoint is an autoclave. It won't work in an autoclave. But if you are using those gamma or ETO processes, that's another advantage to bring to the medical side of things and your parts in general. So we get used to the new normal. The other big thing here is durability. The Z-axis strength here is something that comes natural with this Rizium GF. And you're not only going to get the moisture resistance and the chemical resistance, but you'll be able to apply functional texts, communicate parts in a way that you couldn't before. And this part here, this gasket, if you will, I'm gonna pull open my webcam here so you can actually see it. The image itself doesn't do it justice. You guys can see my screen here. How's everybody doing? So this is the part here in my hand. So this is printed in one piece, and you can see just how, not only how large it's in, but the application of these the communication that you can have with the inks, making smarter parts. We've got the logo here in color, and we've got step-by-step process for the assembly procedure here. So you can start getting smarter workflows and getting parts that have strength, and they're just smarter in general. Now, the next thing we can talk about here is the different problems that the Rizium glass fiber material can solve for you. First, you can get assemblies, and this is specific to the X-RIZE system and the release ink, but it utilizes supports that'll easily peel away. So you'll eliminate a lot of the support removal process and some of the techniques that could be health hazards or just difficult and timely to remove. This piece that you see here, this assembly alignment tool, was built in one piece using the release ink and minimal support to allow this part to be printed in one piece and basically take it off the printer and it's functional. With the 2XC, the Rizium support material is going to be another offering that's going to provide another safe solution for FDM style support removal. Next, parts can withstand multiple directional forces. This is the complement that you get with the added Z strength. You'll be able to create thin walls. Composites, the Rizium composite can create thin walls that are less than 3 millimeters. So you get stronger, more complex parts that are functional, expand your potential applications. You're getting a level of stiffness and complex curved surfaces you're able to do. Again, helped by the Z strength of the material. You get cost-effective color options and reduced warping on some of the more larger parts that you would try and attempt. As you can see, the part we just showed on the webcam, that's possible because of this material. And of course, some added reinforcement to your holes and inner geometries because of that added Z strength. But now let's hand it over to our friends over at Azoth, Cody and Ronnie, and you guys can tell us more of your hands-on experience and what you guys saw.
Hello everyone, my name is Cody with Azoth, and I'm going to get things kicked off here, a little overview, and then hand them over to Ronnie, who's one of our applications engineers and our applications engineer who runs our polymers area and has a lot of hands-on experience with RIZE. So thanks for having us, RIZE. You can see in the top right picture here at Azoth we have many RIZE machines, and we've been using the technology for a few years now, and so we're pretty excited about Rizium glass filled for quite a few reasons, as Ronnie will dive into. So we've been in the beta program since April of this year, and we've been able to learn and utilize the applications engineering support from RIZE to develop different applications here at Azoth. And so we have a lot of experience, whether it was Rizium white, Rizium black, using color, using Rizium carbons. We've had a lot of experience with all the materials line up from RIZE, and I would say this is by far the material that we're most excited about. I think one of the big ones, and Ronnie will dive into why, is low warpage. We're able to utilize the full build plate, whether that's a really large part, large surface area part, or whether that is multiple parts that are just filling up the build plate. We can do that with Rizium GF, and we struggled with that on some of the other materials. The ability to add detailed color is something that I know our customers are excited about, whether that's text, adding text and part numbers to a component, and then the full color ability is just, it really blows people's mind every time they come in here and see a full color part. And glass filled allows us to do really complex geometries on there. One of my favorite things, especially because we utilize all sorts of different technologies here, I like that we can have complex overhangs that need to be supported that are just easily removed by hand, and you don't have a rough surface there. So a lot of competing technologies, we are often having to sand the surface or do something extensive on the supported surface because it doesn't look good afterwards, where with glass filled, we hand remove a support, and that's a surface that isn't a concern to our customer. It isn't a concern to us when shipping. And then I touched on it here, but it's really application development with RIZE has been great. They're able to support us really cradle to grave as new applications come in that test our capabilities. So I think the presentation, did something change on the presentation here?
Sorry about that. I got that.
It's okay. And then as we come back, I was just going to speak to a few of those pictures, so hopefully we can get the presentation back.
Sorry, don't know what happened there. How's that?
That's great. And so if we look at some of the applications that I've shown there along the right, on the Rizium white, we're excited to replace components like that with glass filled because we think they'll actually last longer and the support removal will be a little bit better on those. So that's an exciting application for us. And even the bottom picture in Rizium white, we're looking to replace that with Rizium GF as well, just for the stiffness that it provides. So we think we'll be able to increase tool life on those components. So I'll actually hand it over to Ronnie and let him dive into some of the details of our development of this material at Azov. Next slide, please.
Hey guys, so some of the problems that we've used glass filled to solve here for us has been some stuff with texture, but overall at Azov, a large part of what we do is a lot of end-use components. Although there's prototyping and there are some things, there's a lot of things that are going to be used in the field that maybe still need cosmetic color or still need to be handled by 50 different people during a product development seminar or some sort of trial. But then it could also be in a manufacturing facility with oils and chemicals in the air that is in a machine every day that's a part touching, part holding mechanism. And so that's why we get excited for glass filled, is that you have a material that can withstand and meet all the durable requirements, but you also have the ability to add the ink or the text or full color. Like you see the skateboard right there has a wood grain texture to it. That's for if you want to see a full cosmetic part, end use, how something's going to look, but you want to be able to drop it off your desk or give it to 50 people and not have to tell them to be careful with it. This is a part that is really durable in that regards. The picture on the left is a common block that we do for some of our customers for part holding or part touching in a manufacturing environment. And on the front side, you see an Azov logo there, and on the back side, you'll see there's a part number that's marked right into it on a vertical surface. And having the ink to be able to do that, when we had Rizium carbon before, it's really hard to make out the ink against a black background. As soon as you have that the more opaque material, then you can see the ink a lot clearer. But then you're able to also have the dimensional capabilities on the machine to have an end-use part that's not going to break, that you're not going to have to rescale or resize. This is something that can be used kind of right off the machine, direct into a machine application. Go ahead and hit the next slide, please. So then, what are some of the things that we've done with glass filled that are different? So this part here on the right is a massive part. It's the entire build plate, and it's about a ½ inch short of the entire Z height. This is a part that is used to hold machining components in an industrial facility. You see that some of the sizing is marked on top right into the part. Like kind of Alex talked about before, it's not just kind of sprayed on top of the part, but you actually have cohesion with the material, and it's in there. It's not going to easily wipe off on the top layer. On the part to the left is another larger part of a flat part that's also an end-use component that requires some of the chemical resistivity that the RIZE materials give you overall. But these are great examples of parts that are end use, that aren't prototypes, that are going to a customer's facility, that are going to get beat on and abused in their environment, not just to look pretty. And so it's cool to have a material that allows you to go full color if you need it to, whether that's to show FEA or stress risers in a part, so the engineers can see that and handle that and test it and still be able to see that data, or whether you're sending it to a cosmetic client, or that's what you do, and you're trying to have 50 different employees handle a part and see how they like it and see how it does. You're able to do end-use components that have color where you want them, but still have the peace of mind of the durability of something that's going to last. It's a large part of what we do, and that's what we've been really excited for, and pretty much primarily use glass fill now as kind of the takeover for our materials here. Is we'll go from printing fine details on one print, and the next print will be a large blocky part. And although they're vastly different, they both have great properties as far as strength goes, and regardless if it's a small part or a large part, the ink always comes out great on them. That kind of wraps up these two slides on our end-use components for glass-filled, Alex. But as we have any questions or going into it, I can help field some of those as well.
Sure. Yeah. Well, thank you so much, both of you guys, for sharing your experience, and I really appreciate it. If anyone has any questions, we've got the chat open for another minute or so. And obviously, if you need to reach out, if you have any other further questions, my info's here on the slide here, so feel free to take that down and reach out. But just to fill a little bit of time here, Ron, it was something we were talking about yesterday, just the value of how easy it is to work with the GF material, and I think it's a point that can't be overstated. Do you mind telling a little bit about that?
Yeah, absolutely. So there's certain materials, whether you're printing with a polycarbonate or other exotic material. Let's say it's even an ABS, and you don't have a heated enclosure that can kind of give you issues while printing. Whether that's not sticking down to a bed, and you have to deal with part warpage, or have to go extremely hot, and it just doesn't look as good as you'd like it to, especially if it's an end-use component or a cosmetic component that you want to use color for. That can become hard. So it's always nice to have that go-to material that, like I said, regardless if you're printing a large part or a small part, you're nearing the end of your day, and tomorrow morning you want to come into the office and make sure that your prototype's ready. That's what we've kind of found that glass filled is there for. It prints extremely reliably. The prints are always extremely consistent as far as surface finish goes. And then I would say out of all the RIZE materials, glass filled, the supports seem to pull off the best. It's a difference. It's not a pop. It's more of a peel with the glass. But I would say overall that even that surface that's supported, so if you look on the build plate right here to the left, that entire bottom part has that wrap that it's printed on. That whole surface will be consistent and looks fairly similar to the top. And a good example of that is if you look to the part to the right, the top of that part where the numbers were, that was actually part of the part that was down on the build plate. So that top surface is, we have confidence in giving that to our customer, and that's the surface that they see every day, and that's the part that we put down against the support, and have really good success with that. So I think that's maybe a usability, and from a user standpoint, that's one of the best benefits. Is everyone always talks about cool materials and cool properties, but how does it print? What's your user experience going to be like when you get it in your facility and you're trying to print 5 prints a day on small parts, and then do a 12-hour print overnight so it's ready for you in the morning when you get into the office? That's definitely usable. Then you can get multiple day prints depending on the layer height, which is something that we have on that large, the entire build volume part, and obviously completed with success for us as well.
Thank you, really appreciate it. No, it's a great point. I'm looking at some of the questions here just before we close out. Yeah, so Charles, it looks like we may have just answered your question. as you can see on that part on the right there. The question was, you said the ink permeates the GF. Does the part look the same from the bottom as the top then? I think that part gives a good example of that.
Absolutely, yeah. And like I said, that's a part that's the entire build plate down. So it's a large area that you have support on because every part is printed with a raft. It's not nothing's printed direct to the build plate. So that entire face of the part was touching the raft, and so you can see that you get text on the bottom side as well that's against the support. And then you also see on a vertical surface that's not flat, you see the Azoth logo, which turned out extremely well.
Got another question here from Charles. Is color, and you may be able to touch on this, is color better on GF than the white? Or I'm guessing that
and that might be subjective, I guess, between person to person, but it's our opinion here at Azoth. We prefer to give color to our customers in the glass fill. It's not quite as like a super high gloss. It's more of a, I wouldn't say, it's like a semi-matte finish. And I mean, we seem to our customers seem to really like that, and it turns out extremely good off the printer. Like I said, it's not a super high gloss. I'd say more of like an ST would be a taller, a brighter finish there as an end-use component. But I think the color accuracy is definitely a lot better with the glass filled in it. It makes the part look a lot better overall. I think a little bit more consistent color.
Awesome. Let's grab one last question here. I saw this from Akil, and would again love your guys' experience. Better coming from you guys. What makes you think that Rizium GF is better than other continuous carbon fibers in general?
So we have other fiber printers here in house at Azoth, right? RIZE isn't the only printers that we have, but what's different about you using a RIZE versus other continuous fiber filament or fiber reinforced filaments is that you have the ability for part marking, for part color, and then the support surfaces, right? So for anybody that doesn't have a lot of background on RIZE, right, you have the color inkjets, but then you also have your release inkjets in the heads. So not only are you inking down color, but any support interface surface, you have that support ink that is giving you a much smoother finish where the support goes. For anybody here that's printed with a single material support before, normally the underside is very stringy and not very dense. But as soon as you're able to put that ink there with the support, you're able to get a lot more consistent support finish so that your part on a support side or a top side surface or a bottom side surface looks uniform overall. And then the kicker to that is that now with the ink heads as well is that you're able to add part marking right into the part. So sometimes the challenge we see here is that people want text embossed or debossed on the part, and so sometimes on a vertical surface that can cause issues or doesn't always look the best. So being able to mark that in there instead of having to waste a little bit of extra time on the print, maybe you save 20-30 minutes per print, not having to print that text into the part. And then as soon as the X-RIZE came out, now you have full color with the glass filled. I think that, if you look at anybody and say, hey, can I take a reinforced carbon fiber part or a reinforced glass filled part and have that strength, but now I can make it any color and shape I want. Now you get to use that not just for a monotone part, but you can use it for end-use components that normally would be multiple different materials. You can get a good idea for product development or any type of part, what that would look like, or maybe you just want your logo on it or your part number on it. You don't have to, send it to a laser afterwards or put a label on it that's going to peel off.
Thank you. No, that's a great breakdown. I appreciate that. We are running. We're at the stop mark here. I want to thank our friends over at Azoth, Cody and Ronnie. Thank you for being a part of this and sharing your experience.
Absolutely. Thank you. Absolutely, guys. Thanks for having us. Hopefully everybody got a good dose of information here.
Yeah, thanks again. And anyone else, the questions that we didn't get to, we'll be following up with you. If you have any other questions, rize3d.com. You can get the spec sheets And you can also check out, I believe, the shop as well if you're looking at any kind of pricing. And obviously, feel free to reach out to me here, alex.orfanos@rize3d.com. And we hope you have a great rest of your day.